cycle.
All right, let's go for it. But first, what exactly is carbon?
Like water, carbon is a form of matter. And like water, carbon is a basic ingredient for life on Earth. Carbon comes in many forms, such as coal, charcoal, and graphite. If you've ever used a pencil, then you're pretty familiar with graphite. You have used a pencil before, right?
Without carbon, life on Earth could not exist. And without the proper functioning of the carbon cycle, Earth processes would end up more jumbled than a cubist painting.
The carbon cycle is a bit more complex than other matter cycles. Like if the water cycle were one of those old wooden roller coasters that goes up and down a few hills, the carbon cycle would be one of those metal roller coasters with corkscrews and loops. Are you sure you're tall enough to proceed?
Let's start slow. What are the reservoirs for the carbon cycle? You know, the places where carbon is stored for a while before moving along in the cycle.
Did you think that reservoirs were just for water? Guess again. All matter cycles have reservoirs. When we use this word, we just mean a place where the stuff is stored for a while. It could be stored there for a few hours, like water in clouds, or several years, like carbon in the ocean.
Did you catch that? The ocean is one of several carbon reservoirs. Another carbon reservoir is the atmosphere. Carbon also hangs out on land, mostly in plants, soil, and rocks.
Let's see how the cycle works already, shall we? Okay, here we go.
Ever heard of photosynthesis? If you have, then you're already pretty well versed in one part of the carbon cycle. If you haven't, here's the gist.
Plants take in carbon dioxide gas from the atmosphere and use it to make sugar. When living things use sugar for energy, they release carbon dioxide back into the atmosphere. This is called respiration.
Notice that the combination of photosynthesis and respiration makes it so that the amount of carbon in the atmosphere always stays about the same. This is very important. Know why?
It's because too much or too little carbon in the atmosphere could spell trouble for the planet. But we'll get to that later. For now, just know that an important part of the carbon cycle is that it keeps the amount of carbon in the atmosphere relatively constant.
Wow, that roller coaster's got a lot of loops. And so does the carbon cycle. In fact, you might say that the carbon cycle is made of many mini-cycles. Each one involves carbon going back and forth between the atmosphere and some other reservoir.
Photosynthesis and respiration are just one of these mini cycles. These processes involve an exchange of carbon between the atmosphere and living things on the planet. By the way, when scientists refer to living matter on the planet, like the bodies of plants and animals, they refer to it as biomass. So biomass is one reservoir for carbon on Earth.
Now that we've seen the way carbon cycles between the atmosphere and biomass, let's check out another loop in the carbon cycle. This time we'll see how carbon cycles from the atmosphere to the oceans.
When carbon finds its way into the ocean, marine organisms use it to build shells, skeletons, and other tissues. When these organisms die, the carbon from their body settles to the bottom of the ocean and is eventually returned to the rock cycle.
Dissolved carbon dioxide in the ocean can undergo a slew of different chemical reactions, creating carbonic acid, carbonate, and bicarbonate.
Whoa! TMI. I'm not sure we really need to know all that much about what carbon does in the ocean. Ease up on the dirty details, will ya?
Oh, sorry, how, awkward? Just know that carbon gets stored in the ocean, okay?
And we're talking lots of carbon. The ocean stores 20 times the amount of carbon that is stored in biomass.
Carbon stays in the ocean for a long time. It could stay there for hundreds of years before being released back into the atmosphere as carbon dioxide. But remember, in the grand scheme of geologic time, 500 years is a blink. So the ocean is a pretty active participant in the carbon cycle. It's constantly exchanging carbon with the atmosphere.
Are you ready for the bad news? These days, the oceans seem to be absorbing more carbon than they are releasing. This is causing something called ocean acidification. Again, we'll lay off the dirty details, but the point is that the chemical composition of the ocean is changing, and scientists are not sure what effects this could have on marine life.
Sounds like trouble. What I want to know is, why are the oceans becoming more acidic?
Great question. The answer has to do with the ways that human activities are affecting the carbon cycle. We'll learn about this in a moment.
But first, Let's check out one more loop in this carbon cycle roller coaster. This time we'll see how carbon cycles from the atmosphere to rocks.
It's true the oceans contain a lot of carbon, but rocks form the biggest carbon reservoir on Earth. Rocks contain something like 50 million gigatons of carbon. That's a lot. But how does the carbon get there?
As sedimentary rocks build up over time, they accumulate large amounts of carbon. For example, limestone is a sedimentary rock that is made from the accumulated skeletons and shells of dead marine organisms piled up on the ocean floor. You know, limestone. It's the stuff chalk is made of.
Carbon is also absorbed to the atmosphere by rocks through certain kinds of weathering. It is released back into the atmosphere during volcanic eruptions and other processes.
Rocks are total hoarders when it comes to carbon. If you thought 500 years is a long time for carbon to stay in the ocean, guess again. Carbon stays in rocks for something like 1 billion years. As you can see, rocks contain the largest amount of carbon, but they're not exactly the most active participants in the cycle.
Let's review for a second, shall we?
So far, we've talked about how carbon is stored in biomass, the oceans, and rocks. Each of these storage places has its own mini cycle in which it exchanges carbon with the atmosphere. The main idea is for the amount of carbon in the atmosphere to be kept relatively constant.
Now, before we go and let this whole carbon thing fall out the other ear, we need to talk about one last carbon reservoir on Earth: fossil fuels.
You've probably heard of fossil fuels before. They're sort of a hot topic these days. So let's get the story straight.
Fossil fuels are kind of like zombies. That's because they're made out of dead things.
Fossil fuels are materials formed over millions of years from the decomposed body parts of dead plants, animals, and other organisms. We humans burn fossil fuels for, you guessed it, fuel. Coal, petroleum, and natural gas are all fossil fuels.
Humans burn fossil fuels for things like transportation, manufacturing, cooking, heating, and electricity. In other words, we burn a lot of fossil fuels.
When fossil fuels are burned, the carbon they contain is released back into the atmosphere.
Unfortunately, human society is burning fossil fuels at an alarming rate. Something like 6 billion tons of carbon dioxide is being released into the atmosphere each year due to the burning of fossil fuels. That's way more than normal.
Hey, let's get one thing straight. By normal, we mean the rate at which the Earth would naturally release the carbon from the fossil fuels back into the atmosphere. By naturally, we just mean without human interference.
You see, when we humans burn fossil fuels, we're burning stuff that's been under the ground for hundreds of millions of years. And we're burning stuff that would have stayed under the ground for hundreds of millions of more years had we not unlocked it. That's going to have an effect on the planet.
Remember how we said before that the carbon cycle keeps the amount of carbon in the atmosphere at a constant? Well, the burning of fossil fuels is actually increasing the amount of carbon dioxide in the atmosphere. This is not good for the planet.
But why?
To make a long story short, too much carbon dioxide in the atmosphere is causing the planet to warm up faster than is natural, a process called global warming.
You see, extra carbon dioxide in the atmosphere kicks a natural process called the greenhouse effect into overdrive. Under normal circumstances, the greenhouse effect is a beneficial process that keeps the planet warm enough to support life. But too much carbon dioxide in the atmosphere is causing the greenhouse effect to warm the planet up too much.
Global warming is an example of how natural Earth processes can get thrown off kilter due to human interference.
Sure, it's normal for global temperatures to go up and down over time, but this usually happens in geologic time, over millions of years. Global warming is causing the planet to get warmer over time spans as short as decades.
When you think about it, the carbon cycle is like the student council. It's involved in everything. So, as carbon in the atmosphere continues to increase, we can see changes all over the planet. Some of these changes include the acidification of the ocean, changing weather patterns, and shrinking glaciers. Based on what you've learned about the carbon cycle, can you think of what some other changes might be?